All right. So again, the slope-intercept form is y equals mx plus b. And m is the what? Slope. And our b is the symbol for the what? Y-intercept. All right. So we're going to build on this in steps. All right. So the very first part is we're going to take this, and we've been given an equation. We have to write an equation when we're given the slope and the y-intercept. The two pieces we need, right, to write an equation. So if we're given a slope of -2, which is m, and a y-intercept of 5, all right, I'm going to replace m and b with those numbers. So our equation for number 1 would be y equals -2x plus 5. Okay? Pretty simple, right? Replace m and replace b. All right. Now for number 2, notice that our y-intercept is now negative. So again, this is our slope. This is our y-intercept. So when I go ahead to put m in, now b is always, it says plus b, right? So if it's positive, we just change the b part, right? We don't change the sign. When it's negative, the sign instead of positive becomes negative. So instead of writing plus -3, we would just write -3. Okay? Pretty simple to start, right? Not too bad. All right, so here's where a lot of our work with the graphs, why we did this. So we're given two graphs here. They actually were nice and actually wrote the points down for us. So again, the first thing I need to find is the slope. So basically, how high am I going up and how far am I going over? So what is the rise from -5 to 3, -1? What's the rise? What? 4. 1, 2, 3, 4. And what's the run? What's the run? 3. So that means our slope is what? What's our slope? Right, because rise over run, 4/3. All right. Now, what is our y-intercept here? Where is the point? Remember, this is the y-axis, right? Right here. Right, this whole line right here. So if that's the y-axis, what is the point that crosses the y-axis or that touches it? The interception point. That's why they call it the y-intercept. Where's that intersection point, bruh? Huh? This line touches that line? That point? What point touches this line? Yeah, so the y-intercept is -5. Right here, this point, right? That point intersects the y-axis, right? If I erase that, you can see that it's touching the y-axis. This line right here is the y-axis. This line is the x-axis. So again, if I had the slope and I had the y-intercept, I can write the equation as y equals 4/3 x minus 5. I got the two pieces that I need to write the equation. Okay. All right, next one. Now just notice that the line is going the other way, right? So again, what is our rise and what is our run? So we have to go down and over, right? So how far am I going down? Angelina. How far am I going down? I'm going down this way. 2. And how far am I going over? Ivana, how far am I going over? 4. So rise over run, right? So we have -2/4, which can convert to, what can we simplify -2/4 to? -1/2. So our slope is -1/2. Okay. Now, let me erase. I'm going to just erase this real quick, just kind of so you can see it. Where does this blue line touch the y-axis at? Where does the blue line touch the y-axis at? Dean. Right here, right? 0, 1. So the y-intercept is 1. So if our slope is negative 1/2, our y-intercept is 1, what is our equation? What is our equation, Paulina? Right, y equals negative 1/2 x plus 1. Not too bad right now to start? Trust me, you know it's going to get harder, right? So, all right. So starting off, they gave us the points. Well, now if we go to the back page, what do you notice? They take the points away, don't they? And now we have to find them ourselves. Well, okay. Actually, for the first one, number 5, they give us 2 points. They just don't tell us what it is, right? So let's identify these 2 points. What's this point right here? What coordinate is that blue dot I just colored in? Right here. What would I write that down as a coordinate, Brett? 2, negative 3 is right here. Actually, 2, negative 3 is over here. Nick. Yeah, negative 3, negative 2. We're 3 to the left and 2 down. Those are both negative. Okay. Remember, you're in quadrant 3 here. That means both coordinates are negative. Now, what is the coordinate of this point right there? What is the coordinate of that point right there? Xander. 2 zeros over here. If it's on the y-axis, x is always 0. So it's 0, 2. You just had it backwards. If it's on the x-axis, y is always 0. Okay? All right, so we found our 2 points. So let's figure out our slope. And how many do I have to go up? What's my rise? What's my run? What's my rise? Nick? 4. 1, 2, 3, 4. What's my run? How far do I go over? Ethan? 3. So our slope is 4/3, right? Where is my y-intercept? Michaela? Where does that line touch the y-axis at? Huh? 2, 0, 2, right? So our y-intercept is 2. So again, I have my 2 pieces of information. Plug them in. Y equals 4/3 x plus 2. Now for number 6, we have a blank line, no points. So I got to figure out, I'm going to draw in some spots where it touches the grids right at the corners. So there's a spot. Oop, this is a little off. Let's see if I can get this a little bit better. There's one. There's one. There's one. So I've hit all the points where it hits the grids right in the middle, right? So I can pick any 2 points I want, right? But what point's very important to me that I got to pick, that I need? Elizabeth. The one that touches the y-axis. And what's that point right here? What's the coordinate of that point, Brett? Yep, 0, negative 3. So that means our y-intercept is negative 3. So which 2 points do you want to use to count to? I can go right up above it. So I'm going down, rise over run, right? So what is our rise? What is our rise? Negative 3 because going down. And what is our run? Anna, what's our run? Negative 2 would go left. So if we're going right, it's 2. So negative 3 over 2. So again, we got our 2 pieces of information we need. So our equation would be y equals negative 3/2 or negative 3 over 2x. Now again, don't write plus negative 3. It's just minus 3. So when you see that plus sign become a minus sign, you know that your y-intercept is negative. It's below the x-axis. So not too bad with the graphs. Not too bad, right? All right. So now we're going to get into, all right, how are we going to find an equation if we're given a table? So we've done a graph. We've been given a slope and a y-intercept and just wrote the equation, right? So now we're going to do the table here. All right. So one thing about a table is We always want to look in the table to see if any values for x are 0. Because if x is 0, what does that mean? Sander? No, it's not undefined. If x is 0 and we got a y point, what does that mean? Elizabeth? That's the y-intercept. So right here on the very first example, they give us the y-intercept point, right? So our b is 1, right? Right here. Our b is 1. Now it's just finding the constant rate of change of the graph, right? All of our x's are doing what? Increasing or decreasing? Increasing by what? 1. And what about our y's? Are they nice to us here? Is this increasing or decreasing? Increasing by 2 every time. So our change in y over the change in x is 2 over 1, right? Which is, so if our slope is 2 and our y-intercept is 1, Alyssa, what's our equation? Anna, you want to help her? Y equals, the slope is 2, so 2x plus 1, because our y-intercept is positive. Okay? So again, we found our slope in this to be 2. So again, once I find those two things, it's nice and easy, isn't it? Just plug it into the equation. Look at the second one. Do they give us a y-intercept? Again, you always identify the y-intercept at the point, if they got a pair of points where x is 0. Right, is there a point in there? Right in the middle, right? 0, 3. So our b is 3. So again, if we notice our x's here are all going up by 1, right? What about our y's? What do you notice about these y's? Nick? Decreasing by what? Not 1.5. Dane? Huh? Yeah, it's decreasing by a half every time, right? So 4 to 3.5 to 3 to 2.5 to 2. So if I put that change, right, even if you write it as a decimal, 0.5 over 1 is 0.5, right, or a half. Okay, so again, try to stay away from writing slope in a decimal form. So if I write a half over 1, that's still a half, right? It's negative a half, right? Because anything over 1 is itself. So our slope is negative a half. So if our slope is negative a half, our y-intercept is 3, what's the equation for that table? What's the equation for that table? Julia? Very good. Y equals negative 1/2 x plus 3. Okay. So let's look at our third example. Again, do they give us a y-intercept? Alex, do we have a y-intercept here? Yep, is it right here, right? X is 0 right here, so 0, negative 1 is our y-intercept, right? So we know what our b is. Our b is negative 1. But now if you notice, we were nice so far, right? They've been nice to us. Everything was a constant rate all the way through. Well, this doesn't look like it, does it? From negative 5 to negative 2 is how many? 3, right? It's going up or down? Up, right? So we're plus 3 here. From negative 2 to 0, we are plus 2. And then we're plus 3, and we're plus 2. So this doesn't have a constant rate of change, right? So when it didn't have a constant rate of change, when we were just figuring out slope from a table before, what did we have to do? How do we figure out the slope when nothing was constant? Right, the change in y or the change in x, right? So I'm going to erase this b equals negative 1 because we know where that is. So from negative 16 to 7, what's that increase? 9. From negative 7 to negative 1, 6. From negative 1 to 8, 9. And this is 6. So again, change in y over the change in x. So this is 9 over 3, which is 3. All right, 6 over 2. What's 6 over 2? 3. And then these are 9 over 3, which is still, right? And 6 over 2, which is, so what's our slope? 3. That constant ratio, that constant change in y over the change in x. So if our slope is 3, our y-intercept is -1. And Maria, what we got? Y equals 3x minus 1. Pretty simple so far, right? Not too challenging. Like I said, now. So, when we go over to here, so to find the y-intercept is when x is, what should be in that blank? When x is 0. Okay? So, again, if you look at these, the y-intercepts are right here. Right? We saw those, right? In those last 3 examples, they were nice, dead smack in the middle. X was 0, y was some number. That's the point that touches our y-intercept, our y-axis. Okay? Now we're going to find out what happens when, in the table, they don't give us that 0 point. Uh-oh. Okay, we got a little bit of work to do. So that's the next example. So the first thing we have to do is find the slope. All right, so we're going to find the slope first. So if I notice all my x's are going by up 1, are my y's going up by the same thing? From 11 to 15, that's 15 to 19, 19 to 23. So they're all going up 4, right? So what's our slope here? Right, 4 over 1, which is 4. So we found our slope. But we don't know what our y-intercept is, right? Because for x, the x column, there's no zeros in it, right? All right. So it says we're going to fill in the slope into y equals mx plus b. So we're going to plug the 4 into there. Okay. And now it says choose an ordered pair. Remember, these are ordered pairs. That 1, 11 is actually, right? Right? Everyone know that's an ordered pair, right? So we're going to substitute it into x and y of the slope-intercept form and solve for b. So if I look at all these points, what would be the easiest point to use? Remember, work smarter, not harder. Out of all those points, the coordinates, so this is a coordinate, that's a pair, that's a pair. Which one would be the easiest for me to use? What do you think would be the easiest for me to use? What would you prefer, Nick? Yeah, 1 and 11, right? Find the smallest number, right? The less math you have to do, right? So I'm going to plug 11 in for y equals, I have my slope. What's my x? 1, so times 1 plus b. All right, so now that I plugged it into y equals mx plus b, I have a y, I have an x, and I have an m. I don't have b. Now let's just solve for b. Well, what's 4 times 1, everybody? 4. And now if I want b by itself, how do I get rid of the 4? This is where all that solving equations came in handy. Subtract 4 to both sides. And 11 minus 4 is? Not 9, 7. So b is 7. So now I've found my 2 pieces I need, right? I have my slope. I have my y-intercept. So what is my equation? Who's going to give me my equation? Brooklyn? Good. Y equals 4x plus 7. So I kind of used y equals mx plus b to find my b, and then I used what I have to go plug it back in. Okay? Not too bad, right? Takes a little bit of work, but it's not. So that's what happens when they don't give us that y-intercept. They make us work a little bit. I know, big jerks. Now look at the third example. Putting it all together, it says, well, we have to find the slope. So Let's find the slope first. Well, all these guys, nicely for us, are going up by 1, right? And all these guys, do we have a constant rate of change here? 2's, right? So our slope is 2, right? Where's our y-intercept? Did they give it to us in the table here? Xander? What is it? Yeah, right here, right? But if you notice, so this is our b, right? -4, right? But if you notice, we also have this. Is that a y-intercept? No. What is that then? Elizabeth? An x-intercept because y is 0. We don't need that, do we? No, we don't. But now this is the first example we've seen with 2 zeros in it, right? So note the difference between a y-intercept and an x-intercept. And a y-intercept x is 0, and an x-intercept y is 0. So since we have our two pieces, our equation is 2x minus 4. Not too bad. So-so. All right, we're in the home stretch here when we get going with your homework. All right, so let's flip it on over. All right, so now we got some uglier looking tables here, don't we? Bigger numbers. Notice the first table. Do we have an x 0 anywhere? All right, so we got to figure it out, right? All right, so let's find our slope first. Well, as I look here, this kind of goes all over the place, right? +2, +3, +2, +3. All right, and then over here, we're +8, +12, +8, and +12. So again, we got to go the change in y over the change of x, right? So 8 over 2, because we're doing the first set of changes here, and here. 8 over 2 is what? 4. And 12 over 3 is 4. And then we already figured out 8 over 2 and 12 over 3. So what's our slope here? 4. All right, so now we got to figure out our y-intercept, right? Our b. How are we going to do that? How did we do that just a little bit ago on the previous page? What did we do? Michaela? Right, we got to plug in y equals mx plus b, our slope that we found, and pick a point, right? What's going to be the easiest point to use here, Michaela? Yeah, use the first one, 2, 5. So where y is, plug in a 5, plug in the m for the slope, 2 for x, plus b, and solve for b. What's 4 times 2? Oh, what's 12 times, or 4 times 2? 8. Now, how do I want to get b? I want to get b all by itself. Brianna, how am I going to get b all by itself? What do I got to do to this 8 to get b all by itself? Subtract it, right? Do its inverse. So if I subtract 8 to both sides, that goes away. And 5 minus 8, Anna? -3. So our b is -3. Our m is 4. What's our equation? Y equals what? Ethan, you know? Not just -3. We got to put our slope in there too, right? No, you put our b in for slope. Alec, you want to help him? 4x minus 3. Right? Remember, our m is mx plus b, right? Okay. Now our other table, okay, a little different. We got a 0 in there, right? Is that the right 0 we need? Yeah, it's in the x column, right? So here is our b value, 4. So all we got to do now is find the slope. Well, that was nice of them. By looking at it, though, it doesn't go the same every time, does it? +2, +3, +3, and +2. So they're going to make us work a little bit. Now, is the y column, is that increasing or decreasing? So this can be negative every time, right? 10 to 4 is -6. 4 to -5 is -9, right? All right, so again, change in y over the change of x. So -6 over 2. Negative 3. And what's negative 9 over 3? Negative 9 over 3. Zach. Negative 9 over 3. 3? Negative divided by positive. It's negative 3, right? All right, so our slope is negative 3. Our y-intercept is 4. So what's our equation? What's our equation? Negative 3x plus 4. Not too bad, right? Now the last part is taking an equation in slope-intercept form and graphing it. This is a nice, easy task if you just make it easy on yourself. So if we have y equals 2x plus 1, what do we know our slope is? What's our slope? 2. What's our y-intercept? 1, right? So where's the point 0, 1 at if I start from the origin? Am I going up, down, left, or right? 0, 1. Where is 0, 1 on the graph? Come on, where's 0, 1 on the graph? Josh, where's 0, 1 on the graph? If I start here, which direction am I going? Down. Down? 0, 1, y-intercept. Up, right here. Okay? So that's the first point. That's my starting point. Now I'm going to use my slope to find point number 2. Well, if my slope is 2, what's rise over run if my slope is 2? Rachel? If my slope is 2, what's rise over run? If my slope is 2. Think about it. If my slope is 2, what's rise over run then? How am I going to know to go from this point? Up 2. Not over 2. If Anna Maria, if my slope is 2, I'm going up 2 and then over 1. Because, right, we write a whole number, we can write it as 2 over 1 equals 2, right? 2 over 2 equals what, Rachel? If I take 2 over 2, does that equal 2? 2 divided by 2 is what? Is 1, right? So anytime we have a whole number, it's always 1 to the right. So we're going up 2 and 1 to the right. So there's my second point. Well, guess what? I can make my line. Not a very straight line, but my line nonetheless, right? That's how easy it is to graph a line in slope-intercept form. So look at the second one. Negative 2/3 x minus 2. What's my slope? Negative 2/3. What's my y-intercept? 0, negative 2. So again, where am I going to plot 0, negative 2 on the graph, Owen? If I start the origin. 2 this way? That's a y-intercept? 2 down, right? Y-intercept goes up and down. So right here, right? Now, I got 1 point. So my slope is negative 2/3. So what direction am I going from this point to make my second point? Paulina, what direction am I going in? Down, how many? Down 2, and then where? Over 3. Down 2, right 3. There's my point. Here is my line. Now, of course, I always got to throw one at you, right, to make things tough. Look at down here at the bottom. What's wrong with that? Can we just graph that right now? Why? It's not in slope-intercept form, is it? So why do we do practicing on that? Because of this, right? Now, this is kind of different from anything we've done so far, right? Because x's and y's are on opposite sides, right? So what do we got to get rid of? I got to get y by itself. No, I don't get rid of x. Elizabeth? The 8, right? If I put the 8 over here, I got it in y equals, right? So how do I move minus 8 across the equal sign to the 2x side. Emma? Add 8 to both sides. So if I add 8 to both sides, I get 4y equals 2x plus 8. All right? We're almost there, right? What's the last thing I got to do to get in y equals? Y equals, Michaela? Divide the whole thing by 4. So this becomes y, because that becomes 1. 2/4 is 1/2, right? And 8 over 4 is 2. So guess what? What's our slope? 1/2. What's our y-intercept? 2. So where do I graph the point 0, 2? Rachel, redeem yourself. 0, 2. Which direction is 2? Up, down, left, or right? From here. Up. Right here. 0, 2. And now what is my slope? My slope is 1/2, Brooklyn. So where are we going from this point? If the slope is 1/2, from this point I'm going up 1 and over 2, which puts me right there. And there is my line for that equation. Okay. Well, we're going to stop this. Hold on here.